All right, look, if you're in high school right now, staring down a whole semester of Algebra 1, and you're thinking, I want the absolute most information possible so I can literally guarantee myself an A+, well, you are in the exact right place. Let's jump right into this explainer, which is basically your ultimate cheat sheet blueprint for completely dominating elementary algebra.
Now, as we can see here, it's just like building a massive skyscraper. Your algebra skills need a rock-solid foundation before we can even think about building up to the really complex stuff. I mean, you wouldn't try to build a luxury penthouse on a swamp of quicksand, right? The exact same logic applies to math.
So here is our structural roadmap for today. We're going to cover building your math foundation, the language of algebra, graphing linear inequalities, solving systems of equations, and finally, polynomials and factoring.
Okay, let's lay down that concrete. Part 1. Building your math foundation.
Before we can do any of the cool advanced algebra, we have to define the basic materials we're actually working with. And that starts with counting numbers. You know, exactly what they sound like, what you use to count physical things, starting at 1, 2, 3. But when we introduce 0 into that mix, we get what are called the whole numbers. I know, it sounds super basic, but trust me, knowing these strict definitions is exactly how you avoid those silly, point-costing mistakes on your exam.
And this place value chart is actually pretty wild when you think about it. It visualizes place values all the way up to the trillions. It's a great reminder of how our number system scales up. Whether you're dealing with a single digit in the ones column or you're navigating the 100 billions, the underlying structure of our math system stays remarkably consistent.
All right, with the concrete poured, let's start framing the walls. Part 2, the language of algebra.
Okay, this is a massive deal. You absolutely have to understand the difference between an expression and an equation. An expression, like 3 plus 5, is just a phrase. It just sits there, no action. But the second you add an equal sign to make it an equation, boom, that equal sign becomes the verb. It definitively states that one side is identical to the other. Grasping this simple concept literally turns algebra from a random jumble of numbers into a totally readable language.
And just like any language, math has grammar. We use these specific operation symbols. When you see a plus sign, you're looking for a sum. A minus sign means difference, and multiplication yields a product. Being able to instantly translate a messy word problem from English phrases into this precise mathematical grammar, yeah, that's a huge secret to securing that A+.
Let's level up. Section 3. Graphing linear inequalities.
Okay, here is your A+ pro tip. Graphing an inequality essentially comes down to 3 foolproof steps. Honestly, just memorize these and you'll never get stuck. First, you graph the boundary line and pay really close attention to whether it should be solid or dashed. Second, pick a super simple test point that is not on that line. And third, just shade the correct side based on whether that test point makes the inequality true or false. Easy, right?
Notice how this boundary line is dashed. Why? Because our inequality is strictly greater than. It's not greater than or equal to. If there was that little or equal to line underneath the symbol, we'd draw a solid line instead. It seems like a minor visual detail, but it is fundamentally crucial to the mathematical truth of the whole graph. So, after testing the point 0, 0, we find that it's a valid solution. That means we shade in the entire upper side of the boundary line to visually represent all our possible answers. Literally every single coordinate point in that entire shaded region is a correct answer that satisfies the inequality. How cool is that?
Moving right up the structure, we've arrived at the complex plumbing and wiring of our algebraic building. Section 4. Solving systems of equations.
Word problems can be an absolute nightmare, right? Well, this 7-step strategy is basically your master key. If you rigidly follow this sequence, starting from reading the words, to identifying exactly what you're looking for, naming variables, and eventually checking if your answer actually makes logical sense, you remove the guesswork entirely. Memorize this and you will confidently tackle literally any system of equations they throw at you. And check out substitution, which is one of the key algebra techniques from step 5. It's almost like a magic trick. Because we know that n is equal to m minus 9, we can just seamlessly drop m minus 9 directly into the n spot in the other equation. Just like that, a complicated, messy system with 2 variables transforms into a totally straightforward equation with just 1.
All right, we made it to the penthouse. Section 5. Polynomials and factoring.
Now, before we can factor them, we have to define what a polynomial actually is. It can be a single chunk of numbers and variables, which is called a monomial, or multiple monomials strung together with plus and minus signs.
Also, get into the strict habit of writing them in standard form. That means the highest exponent comes first, then the next highest all the way down. It's a total hallmark of a top-tier math student.
You've probably heard of this one, the legendary FOIL method. It's an essential acronym for multiplying two binomials by combining the first, outer, inner, and last terms. By systematically following FOIL, you guarantee that every single part of the first binomial gets multiplied by every part of the second one. It just keeps all your work perfectly organized.
Another absolutely crucial tool for the top floor is scientific notation. It allows us to easily handle incredibly massive or totally microscopic numbers using powers of 10. Honestly, you just move the decimal until you have a number between 1 and 10, count the jumps you made, and bam, that becomes your exponent. It's just a really elegant, structured shortcut for dealing with messy, real-world numbers.
Finally, when it comes time to break these expressions back down, this general factoring strategy is your ultimate checklist. Notice step 1. Always check for the greatest common factor first. Seriously, don't skip that. From there, just count the terms. Binomial, look for squares or cubes. Trinomial, try to undo FOIL. It takes a scary, intimidating problem and turns it into a simple game of categorizing. So your foundation is set, and all these powerful structural tools are completely at your disposal. The only question left is, how are you going to use this blueprint? Because listen, algebra isn't just about passing some high school test to get an A+. It is the fundamental logic used to code software, engineer real-life skyscrapers, and literally decode the universe. You've got the foundation now. What are you going to build with it?